All right, so this video is going to cover the discussion questions from Wednesday, October 28th. That was the day of the Pep Fest. So some people were unable to participate in the discussion, so I thought I'd make this video so that you can at least go through the questions and understand the answers to the questions. So let's go ahead and start with number one. What does periodic mean? The word periodic simply means in a repeated pattern. And so there's a reason why we use that term to describe the periodic table, because the periodic table is organized in a very sequential pattern. The elements are not just thrown up there randomly. So that's why we use that word to describe it. Number two, who came up with the periodic table? How was it organized? And how is it organized now? So the guy who came up with the periodic table, his name was Dmitry Mendeleev, and this was his original periodic table that was published in 1871. So you can see it looks obviously very different from the periodic table we have nowadays. But you can see some similarities as well, as you see some of the different symbols and atomic masses and things that are listed on there. So Mendeleev's periodic table was originally organized by atomic mass. So the numbers you're seeing on here are atomic masses, not atomic numbers. Later on, the periodic table was rearranged to be arranged by atomic number, and so we look at the modern periodic table here for today, and we see that it's arranged by atomic number, not atomic mass. So that answers number two on the discussion questions. Number three, the first periodic table had spaces left open with question marks. Explain why those question marks were there and how they knew to put them in such specific locations. So if we go back to Mendeleev's periodic table, you can see that there are some blank spaces left open with masses, but no symbol names or anything like that. There are also just some blank spots as well. So Mendeleev was able to obviously identify a pattern within the elements, and you can see that he put them in groups as well, just like we have nowadays. But basically Mendeleev figured out a pattern and where basically we'd be able to put the missing elements. So just like you guys actually did today in your alien periodic table lab, he was able to identify those missing aliens, or in his case, the missing elements. So you guys did a very similar process to what he would have done. Number four, compare and contrast electron cloud and energy levels. The analogy I used in class that some of you probably heard already is that the electron cloud really is like the building, and the energy levels are like the floors in the building. So if you think about a building, even like our Rogers High School, you think about the fact that the full building from ground to roof would be the electron cloud, and first floor and second floor would be the different energy levels within that electron cloud. So the electron cloud describes the big area around the nucleus, whereas the energy levels describe a more specific area. Number five, what are the capacities of the first four energy levels, and what implications does this have? So the capacities are: the first energy level holds 2 electrons, second energy level will hold 8, the third will hold 18, and the fourth energy level holds up to 32 electrons. What implications does this have when drawing Bohr models? By now, hopefully you know that when you draw a Bohr model, these capacities come into play because you cannot place more than the capacity number of electrons within an energy level. So the first energy level can only hold 2 as a maximum, so that's how many you can put into that level. The second one holds 8, so you can put less than 8 in it, but you cannot put more than 8 in that energy level. Number 6, draw the Bohr model for an atom of fluorine. Include protons, neutrons, and electrons. So the first thing we need to do for this is figure out how many protons, neutrons, and electrons an atom of fluorine has. So if we go to our periodic table, fluorine is over here on the right-hand side, number 9. So since it is number 9, that's its atomic number, which we know it represents the number of protons. So we know right away that it has 9 protons. The electrons are always going to be the same as protons, as long as it is a neutral atom, and for now you can assume that all atoms that we refer to are neutral. So it's going to have 9 electrons, it's going to have 9 protons, And in order to figure out neutrons, we need to look at its mass. So its average atomic mass is 18.99 blah blah blah, and we know that we can take that number and round it to the nearest whole number, and that's what we call its mass number. So 18.9 we can round to 19, so if we take its mass number as 19, that tells us protons and neutrons. So if we take protons and neutrons and minus the protons, which in this case is 9, we're going to be left with 10. So now we know that fluorine has 9 protons, 9 electrons, and 10 neutrons. So this is what a Bohr model for fluorine should look like. In the nucleus you have 9 protons and 10 neutrons, and then in the first energy level there are 2 electrons, second energy level there are 7, for a total of 9. Okay, and remember the capacities of the second energy level would be 8, so we're right at 7, we're close to the capacity. The first energy level has just 2 in it because it's already at its capacity. Okay, so that's what a Bohr model should look like for fluorine. So if we go back to our questions here, we'll go to the next slide for number 7. Number 7, you're listing at least 6 things you can learn about an element simply by looking at the periodic table. So we're going to go back to our periodic table, and I'm going to pull up beryllium here. Beryllium is number 4, so right away we know its atomic number. We also know that that is the same as the number of protons. We know its symbol, which is Be. We know its name, which is beryllium. We know its average atomic mass. We know its mass number. And so from its mass number, we can determine neutrons. And this particular periodic table also shows us what's called an electron configuration. The two little 2's up here in the right-hand corner, those tell you the electron configuration. So that tells us that there's 2 in the first energy level and 2 in the second energy level for a total of 4. So there are a lot of things you can learn about an element simply by its location on the periodic table. Number 8, think about the patterns and trends in each group and period on the periodic table as you move left to right and top to bottom. Identify as many similarities and varying traits as you can. So let's go back to our periodic table, and hopefully we know now that what we call a group is what goes up and down, and what we call a period is the rows that go across. Okay, so you've got groups, or sometimes called families, going up and down, and you've got periods going across. Okay. Now within each of these groups and periods, just like in your alien activity that you did on Friday, there are things that stay the same and there are things that change. So within the groups, things that stay the same from top to bottom are the number of valence electrons, which are the electrons in the outermost shell. So all of these elements in group 1 have 1 valence electron. These ones have 2. We skip the transition metals, we'll talk about those later. These ones have 3, these ones have 4, 5, 6, 7, 8, and so on. So number of valence electrons is a key similarity within a group. Also, their properties is a key similarity. They all have very similar properties to each other. So for instance, all the alkali metals in this left-hand column here, they all react with water in a similar way, and so that's one of their properties. They also all are metals. They're all fairly shiny metals. They have very similar properties. So the 2 things that they have in common are valence electrons and their properties. They also have 2 things that change regularly as we go from top to bottom. One thing that changes is the number of energy levels. So going from top to bottom, it goes from one up here to 2, 3, 4, 5. It's actually the same as the period number as we go across. So that's the thing that changes. Another thing that changes is their reactivity. For instance, these metals react with water, and they react more violently as you go from top to bottom. So cesium is going to react really violently with water. It's going to cause a massive explosion, whereas lithium may just produce sparks. So they react with water, but they change predictably from top to bottom. Going across, there's one key similarity, and that's the number of energy levels. so going across, the number of energy levels is the same for all elements in that period. Things that change are the atomic number. It goes up by 1. The number of valence electrons is going to go up by 1, and their properties are going to change from metals on the left side to non-metals on the right side. So there's 3 varying traits there and just 1 similarity. All right. Back to our questions. Number 9, what is a valence electron? Why are they important? Draw the electron dot diagram. So a valence electron, I mentioned earlier, is an electron that's in the outermost energy level. They are important because they're involved with chemical bonding, as well as they often determine a lot of the properties of the element. An electron dot diagram is going to look like this. I'm going to attempt to draw one here for you, if I can. So I'm going to create a text box here, and we're going to put an E. So we're going to put a just the symbol Ne. So an electron dot diagram is sometimes also called a Lewis structure. And then we're going to basically just add, so it consists of just the symbol plus the number of valence electrons. And so we are going to, let's see, I gotta find my right thing here. Let's see, I need my pencil. And I'm going to use this one. So these dots that I'm trying to draw here represent valence electrons. And so we typically draw them in pairs, and since neon has 8 valence electrons, and we know that because neon is over here, it's in group 18, and all of these elements have 8 valence electrons. So in the electron dot diagram, all it does is it shows the symbol for the element, and it shows how many valence electrons it has, and that's it. So we don't care about protons or neutrons or any of the other electrons. We only care about the valence electrons, which are in the outermost shell. So that's what an electron dot diagram looks like. And remember, that's sometimes called a Lewis structure. Number 10, explain how elements in the same group or column are similar. So this goes back to the question number 8. We talked about how they are similar. They're similar in the fact that they have the same number of valence electrons, and they are similar in the fact that they have very similar properties. So that goes back to question number 8 there. Number 11, what are the 3 main groups of elements in the periodic table? Give an example from each. 3 main groups consist of, if I go to the periodic table here, we have the metals, which are a lot of the periodic table is consisted of metals. The metals cover basically all the way from the left side over to this green staircase right here. So anything left of this green staircase is going to be a metal. So there's the alkaline metals, the alkaline earth, the lanthanoids, the actinoids, which are down below, transition metals, and the post-transition metals. So all of those would be considered metals. The non-metals are all the way on the right-hand side. So you can see those green and blue highlighted ones. Those would be your non-metals. And then you have the metalloids, which make up just this small area called the staircase of the periodic table. So those are the 3 main groups: the metals, the nonmetals, and the metalloids. And they all have different properties. The metalloids are kind of an in-between between a metal and a non-metal. All right. So that covers all of your questions from the discussion on the periodic table. If you feel like you could use more help, please stop in to see me. Otherwise, rewatch this video or reread your section on Cinch. Do what you need to make sure you understand these discussion questions. And I will see you in class on Monday.